Good day everyone, my name is Nathaniel Nocalan and together with this topic is Jemuel Rivero. Our topic is issues in knowledge representation. What is issues in knowledge representation or what is in issues in knowledge representation? What is knowledge representation? Knowledge representation is a field of artificial intelligence that is concerned with presenting real-world information in a form that the computer can understand and use to solve real-life problems or handle real-life tasks. A knowledge representation or KR is most fundamental a surrogate, a substitute for things itself, used to enable an entity to determine consequence by thinking rather than acting. The fundamental goal of knowledge representation is to facilitate inferencing or conclusions from knowledge. The issues that arise while using KR techniques are many. Some of these will be explained by Jemuel Rivero. There are 5 issues in knowledge representation. First is important attributes. Second, relationship among attributes. Third, choosing granularity. Fourth, set of objects. And 5, finding right in structure.
So again, good day everyone. So the first issue in knowledge representation is the important attributes. Any attribute of objects so basic that they occur in almost every problem in the domain. So there are two attributes, instance and ISA, that are of general importance. So instance, I guess kahibaw na taon sa ning instance. ISA, it represent the class of objects. So these attributes are important because they support property inheritance. I guess there's no further explanation about inheritance since we already discussed this topic in our first year. So the second issue in knowledge representation is relationship among attributes. The attributes to describe objects are themselves entities they represent. The relationship between the attributes of an object, independent of specific knowledge they encode, may hold properties like inverses, existence of an ISA hierarchy of attribute, techniques for reasoning about values and single-valued attributes. So, inverse, this is about consistency check. While a value is added to one attribute, the entities are related to each other in many different ways. So meaning inverse sila. They must be related to each other. Next, or the second property is existence in an ISA hierarchy. This is about generalization specification, like classes of objects and specialized subsets of those classes. There are attributes and specialization of attributes. For example, the attribute height is a specialization of general attribute physical size, which is in turn a specialization of physical attribute. So based in our example, we can already see that there is an hierarchy. So the attribute you add in the hierarchy is the physical attribute, and below the physical attribute is the physical size, which is a specialized class, and below those specialized class is the subset of those class, which is in our example, the attribute height. So the second is technique for reasoning values. This is about reasoning values of attributes not given explicitly. Several kinds of information are used in reasoning, like height must be in unit of length, age of a person that cannot be greater than of person's parents. The values are often specialized when a knowledge base is created. So meaning, all values that been added should be reasonable. Like the height, based on the example height, it must be in unit of length. It could be in centimeter, it could be in inches, it could be in feet or meters. So anything that is in unit of length, and age that is not greater than the person's parents, the age of the person's parent. Then the last property, or the fourth property, is single value attribute. This is about a specific attribute that is guaranteed to take a unique value. For example, a football player can at a time have only one single height and can be only a member of one team. So single value attribute, based on our example, football player, that player could have only one height. Di siya pwedeng duha kay isa ra man siya katao, and he or she should be a member of only one team. So that means na single value ra jud siya, di siya pwede sa uban, di pwede maduha or mas mudaghan pa. So the third issue in knowledge presentation is choosing granularity. What level should the knowledge be represented, and what are the primitives? So meaning, you have to think of what level. Is it easy? Is it hard or complex? Should there be a small number, or should there be a large number of low-level primitives or high primitives? So high-level primitives or high-level facts may not be adequate for inference, while low-level primitives may require a lot of storage. So choosing granularity. Let's think of an example that is kanang makarelate ta. Let's say, for example, algorithm. In algorithm, you have to take consideration of the time complexity and the space complexity. So you have to i-consider nimo umuhuna-hunaon kung pas-pas ba mo execute ang code, and gamay ra ba ang iyahang consumption sa storage. So it is the same in choosing granularity. You have to choose the better, or ang angayan nga butang ana niya nga system. So the fourth issue in knowledge representation is the set of objects. How should set of objects be represented? There are certain properties of objects that are true as a member of a set, but not as an individual. Let's say, for example, all English speaker can be found all over the world, which is true. We can found, bisag asa tang dapita sa tibok kalibutan, makakita tag mga English speakers, but not all of the English speaker comes from the USA, comes from one country. Many of them comes from different races, different places, and different countries, like the Philippines. Since Philippines is known for best speaker in English, and some of them may be in other countries like the China, Korea, and other Japan and other countries. So based on the given example, it is true that all English speaker can be found all over the world, but not all English speakers comes from one country. So the reason to represent set of object is, if a property is true for all or most of elements of a set, then it is more efficient to associate it once with the set rather than to associate it explicitly with every elements of the set. So pareha sa atong gihatag example nga, dili sila those English speakers comes from different places, pero silang tanan kamao mo English, or all of them can speak English language. So the fifth or the last issue in knowledge representation is finding the right structure. This is about access to right structure for describing a particular situation. This requires selecting an initial structure and revising the choice. Given a large amount of knowledge stored in the database, how can relevant parts are accessed when they are needed? Let's say, for example, since we are in intelligence system, let's think that we are creating a robot with an AI system. For example, pareha sa Japan nga robot nga mo na nagbantay or mo na nagmanage sa tindahan. Every action that is performed on that robot or on that system is stored in its database. But the question is, how can relevant parts are accessed when they are in need? Kanang sakto ba ang ilang gihimo para ana nga sitwasyon? That's the first question in this issue. So while doing so, it is necessary to solve the following problems. How to perform an initial selection of the most appropriate structure. So unsa na to pagpili sa insaktong ang appropriate nga structure nga gamiton ana nga system. How to fill in appropriate details from the current situation. Unsaon na to pag fill in sa mga kinahanglanon nga mga details or mga sakto nga details sa dana nga sitwasyon. How to find a better structure if one chosen initially turns out not to be appropriate. Let's go back sa atong example nga katong robot para sa Japan nga robot nga mo ay nag-manage sa usa ka store. And ato ibutang sila sa situation nga syempre mag-manage, mag-arrange sa mga items, pastaron ang mga naas ang mga sulod sa tindahan. And syempre sa naandan sa robot, if ever na ma-disarrange or matagak nga mga item, iyan ning ibalik sa butanganan. But what if ang item is fragile and nahulog, nabuak? So unsa may buhaton? Unsay buhaton sa mga robot if the chosen initially turns out not to be appropriate, dili siya saktong i-implement na nga kay di naman mabalik, kinabuak naman ang mao nga item. So dapat na siya makakita siya better nga structure or better way kung unsa niya pag-solve ana nga problem. What to do if none of the available structure is appropriate? When to create and remember a new structure? So para sa example ganina nga, if ever nabuak unsa ijahang himuon if nabuak naman ang kanay mao nga item, unsa ijang buhaton para ma-fix to nga problem? It's either mag-create siya og kanay pamaagi para or hinluan ba to niya, or na sila'y depende sa system, na sila'y specialized nga mga robots or robot nga mo ay tighinlo sa mao nga tindahan. So what to do if none of the available structure is appropriate? Unsay buhaton kung wala na say option? So para sa atong gihatag example nga di naman wa man na part atong let's just say na wa na tumaapil sa exam pag-program to nga mo hipo siya or mo hinlo siya og mga nabuak nga na. So unsay ijang buhaton adto, and when to create and remember a new structure. Unsaon niya pag-create or kanus as siya mag-create and timan-an in remembering those katong action that is performed in the robot, they are stored in the database. So that's all the issues in knowledge representation. Let's have a recap. The first issue in knowledge representation is important attributes. The second is relationship among attributes. Third is choosing granularity. The fourth is set of objects. And the fifth is finding the right structure. So that's all, and may God bless us all.